So we have a triangle PQR in which angle QPR is 90 degrees, PR is 12 centimeters, and the PQ is 5 centimeters as we have in the diagram here. Now, they ask us for the length of QR in centimeters. You could do this question in two ways. You could do it the long way or you could do it the short way. And interestingly enough, the short way will take up more time in terms of talking on this occasion because it is a perfect teaching moment. So in maths we have these things that we call Pythagorean triplets or Pythagorean triples. What is that? Remember with Pythagoras' theorem, where we have that the square of the hypotenuse is equal to, let us say, the sum of the squares of the other two sides. Good? And I'm using these letters deliberately. H for hypotenuse, O for opposite, and A for adjacent. The same letters that you would use in describing your trigonometric ratios, sine, cosine, and tangent. So a Pythagorean triple is simply three integers, where three distinct integers, mind you, three distinct integers, where the largest integer, okay, let me run that over again. 5, 4, 3, 2, 1, 0, and boom. We have ourselves here a triangle PQR in which angle QPR is 90 degrees, PR is 12 centimeters, and PQ is 5 centimeters. So they're asking us now for the length of QR in centimeters. Now we could do this question the long way or we could do this question the short way. Ironically, in this instance, the short way is what we will spend more time talking about since it is a teaching moment. So there's a thing, if you recall your Pythagoras' theorem from number 3/4 in your paper 2. If you recall Pythagoras' theorem, there's a thing that we refer to as Pythagorean triples, right? Which you would probably meet more than likely when you're actually doing trigonometry, where you're talking about the sine, cosine, and tangent using certain numbers. What is a Pythagorean triple? A Pythagorean triple is a set of three distinct integers. Very important. The integer characteristic is what makes them so special, right? Three distinct integers that conform to Pythagoras' theorem. So in this case, where you have three integers, it means that the largest of those three, the square of that number, will be equal to the square of the sum of the squares of the other two sides. Of course, the largest one would correspond to the hypotenuse of a right angle triangle, and that is why we use H, the letter H here in the equation. So hypotenuse squared is equal to the opposite squared plus the adjacent squared. So in other words, I am deliberately using the letters that you would use, the same lettering that you would use when you're describing your trigonometric ratios. So you have a whole lot of these numbers. Is an almost infinite set of numbers that conform to this condition. But for the purposes of CSEC maths, there are about 3 or 4 that you need to know, that you need to know, that you need to know. Because if you know these, it will make your life a lot easier in terms of answering these questions and in terms of just doing it fast. Because if you know the Pythagorean triple for this, then you could do this in 5 seconds, 10 seconds, okay, 15-20 seconds maximum out of 90 seconds for each question. So let us discuss some of these Pythagorean triples. So the common ones that we need to know for CSEC purposes are, right, 3, 4, and 5, which is to say that 5 squared is equal to 3 squared plus 4 squared. We also need to know this one right here, 5, 12, 13. We also need to know 8, 15, and 17. And then there's the last one. Well, no, let me put I'll put this one first. Let me start with the smallest number, right? 7, 24, and 25. And then you have 8, 15, and 17. So, once you have these three in mind, and you see anything looking like this, then you know what the next line is automatically. So you have 5 here, you have 12 here, the longest line is missing, so the only thing that could be is 13 based on this particular one. We have a right angle, so we are allowed now to use Pythagoras' theorem, which, because it fits into the Pythagorean triples that we know the answer is 13. Right? So you could also have multiples of this. So instead of 3, 4, and 5, you could have 6, 8, and 10. Another common combination. Similarly here, you could have 10, 24, and 26. That you would probably get in a paper 2 where you have the calculator to work it out, etc., etc., etc. So let me just run through the squares of these quickly, just to demonstrate that these numbers in fact do conform to Pythagoras' theorem. We know that 3 squared is 9, we know that 4 squared is 16, right? We know that 5 squared is 25. So in other words, 5 squared is equal to 3 squared plus 4 squared. 25 is equal to 9 plus 16. Same story down here. We know that 5 squared is 25, we know that 12 squared is 144, we know that 13 squared is 169. So 169, which is 13 squared, is equal to 25 plus 144. So in other words, 13 squared is equal to 5 squared plus 12 squared. Same story here. We know that 25 squared is 625. We know that 24 squared is 576. We know that 7 squared is 49. So 25 squared is equal to 7 squared plus 24 squared. Double check it if you have to. 625 is equal to 49 plus 576. And same story down here. We know that 8 squared is 64. We know that 15 squared is 225. And we know that 17 squared is 289. So 17 squared is equal to 8 squared plus 15 squared. In other words, 289 is equal to 64 plus 225. And by that arithmetic, we know immediately that the answer for this is 13 centimeters for QR. Good. So these 4 I would recommend strongly that you know. 3, 4, 5, that is pretty straightforward to remember. 5, 12, 13, 7, 24, 25, 8, 15, 17. So that anytime you see a triangle in a multiple choice question involving these numbers, then you could figure out the remaining number very quickly simply by knowing it and not having to spend a whole set of time calculating it, and then you just move on with the rest of the question. Good. So just for the sake of completeness, I will do this the long way now using Pythagoras' theorem. So hypotenuse is equal to O squared plus A squared. We don't really have a particular reference angle, so O and A could be anything here. So QR squared will be equal to 5 squared plus 12 squared. So QR squared is equal to 25 plus 144, which is equal to 169. So that the QR will be equal to the square root of 169, which is our good friend 13. So even if for some reason you didn't know about the Pythagorean triples here, the numbers are simple enough that you could work them out, remembering of course that you will not have the calculator as an option. So I just want to use that now as an opportunity to remind you that you have to have all your squares and square roots down, right? And I would encourage you strongly to move beyond just 1 to 12 in the back of the copybook. Right? You have 13 squared, 14 squared, 15 squared, all up to 20 squared. So I want to advise you strongly to learn and have committed to memory your squares and square roots from 1 to 20, so that you can maneuver anyhow you see. Anything from 1 to 20, yeah, you could do it because you have it committed to memory. Good. So that is it for this question. So just to wind up again, the answer for this question is answer C, 13 centimeters.